Alright, so 561, we're going to look at some inverse trig functions and then their derivatives. So we'll do this in 2 days, so we'll do some more inverse trig function derivative stuff in the next set of notes. So just recall a little information from pre-calc. When we're dealing with inverse trig functions, your domain is a ratio. So basically what you're plugging in to an inverse trig function are side lengths of a triangle, or you could look at it from a unit circle perspective or whatever, but that is a ratio, and your range, your answers are all angle measures. More importantly, angle measures in radians. So when we're looking at this, arc sine of 1/2, if you forget how to do this, basically what we can do is just say, all right, well, I know I can go back to my right triangles, and here's my angle theta, and then for sine was opposite over hypotenuse, right? So opposite over hypotenuse, so I know the opposite of this angle is 1, and the hypotenuse is 2. And that means that the adjacent side would be square root of 3. And this should look familiar to you. This is the 30, 60, 90 triangle. So that's 30 degrees, but again, we want our answer in radians, so that would be pi over 6. Okay, we're going to go through a couple of these. Arc cosine of 0. Now we can't really look at a triangle here, because if we try and draw a triangle, it's not a very good right triangle. If we try to draw a right triangle, what we're going to do is we're going to end up putting the adjacent, because this would be adjacent over hypotenuse. We would have adjacent of 0, and then the hypotenuse is, well, could be anything really, but so this is going to end up being one of the what's called quadrantal angles. So that means if we're looking at one of the spots on the axes, either the x or y axis, we want to know where is cosine 0. So if we remember back to that, cosine relates to your x coordinate. So where is the x coordinate 0? And that would be here or down here. So the other thing we have to remember is where is the arc cosine function defined, and that would be in quadrants 1 and 2. So this point 0, 1. So if we're looking for a angle measure that would give us 0, that's going to be 90 degrees, or pi over 2 if we write it in radians, which we need to write it in radians, so there you go. Arctan of square root of 3. Again, we're going to go back to our right triangles because we can do that for this one. So we have square root of 3. So let's say if this is our angle, remember tangent. Okay, tangent is adjacent over, I'm sorry, opposite over adjacent. Oops, it's an O, not a theta. Sorry, opposite over adjacent. So this means we could write this as square root of 3 over 1. So opposite would be square root of 3. Adjacent would be 1. That means hypotenuse is 2. And this angle here would be our 60-degree angle, which again in radians would be pi over 3. And the last one, what do we do here? So this is 0.3, which would be like 3 over 10. So we have, this would be like arc. And another thing I should have written here, another way of writing this, you can write this as sine inverse like that in the -1. That's the same thing as arc sine of 3 over 10. So if we look at our right triangle for this, now you can draw a right triangle here. Okay, if this is my angle measure, sine would be opposite over hypotenuse. You could do that, and this would be like the square root of 91. But the problem here is this is not an exact angle measure. Okay, it's not a 45, 45, 90, not a 30, 60, 90. It's not one of the quadrantal angles at 0, 90, 180, or 270. So then how do we do this? And that's basically just by plugging it into our calculator. So on your calculator, again, we're just going to take and plug that in. So sine inverse, you got that function on your calculator, 0.3 to, let's just go 3 decimal places. We end up getting 0.304692654, so we'll just 0.305, since that is what our AP test is going to be 3 decimal places, so we can leave it like that. Okay, so that's all a review of just like some straightforward arc functions, and that's something that you did in pre-calc. I'm not sure if you solved equations using your trig functions or not, but this is something that we can do. So if we have arctan, or basically tangent inverse, we want to solve this for x. We need to get rid of this function because we want that x to be able to come out. So then what we're going to do is we're going to take each side of this and we're going to take tangent of each side. So tangent of arctan, which is the same thing as tangent inverse. You could write negative tan to the -1 if you want. That's not supposed to be a 13, sorry. -3. So we're going to take a tangent of both sides. So we got tangent of all this stuff here, excuse me, and then we have tangent of pi over 4. All right, so if we're going to assume that this is in the domain for arctan, then that means that these two would cancel each other out. So we're left with 2x minus 3 on the left. And the right-hand side, tangent of pi over 4, hopefully you remember that that is equal to 1. So then we just go through our steps here and solve this for x. We get x equals 2. And last one here, again, I think this is something that you did, but I'm not entirely sure. So if we have arcsecant, we're trying to find tangent of arcsecant of square root of 5 over 2. What we need to do is start with our right triangle. So we're going to start with a right triangle. Secant, because it's the reciprocal of cosine, this would be hypotenuse over adjacent. So if this is my angle measure, hypotenuse is square root of 5, and adjacent is 2. So then when we find this side over here, okay, this side over here would just give us 1. Now, this is not a right triangle that we know angle measures for, but that's okay. We don't need that, because when we're trying to find tangent of whatever this angle is, this just gave us theta. All we need to do is we need to know that tangent is opposite over adjacent, and we already have the 3 parts of our triangle. So opposite over adjacent, for this problem, opposite is 1, adjacent is 2. There's your final answer. Again, when we're dealing with this angle measure here, because that's how we filled in the places, the parts of our triangle, was by assuming this was theta. Okay, so you don't ever have to figure out what that angle measure is. You can still get the answer of 1/2. All right, now, calculus. These are your derivative functions for all of your 6 arc trig functions, inverse trig functions. So go ahead, pause the video, and write those down. All right, now, it might look like a lot, and it looks pretty crazy, but basically these are almost identical. It's just this one is negative. Okay, so if you look at sine and cosine, same exact inverse trig function derivative, it's negative. Same thing for tangent and cotangent, secant and cosecant. Okay, so whenever we are dealing with the cofunctions, okay, I don't know if that's something you talked about in pre-calc or not, but sine and cosine are cofunctions. So they are the same derivative, it's just the ones in the right column over here are negative. So don't feel like there are 6 of them you have to remember. There's 3 of them you have to remember, and then they're just negative. You just have to remember that their cofunctions are negative. So again, another way you could see this written would be, would be like 1 over square root of 1, we'll make that 1 visible, 1 minus u squared, and then times du dx. Okay, that's another way of writing u prime. So you could see it written like this, where the derivative, this is basically just saying chain rule. If u is some function other than just a straightforward x, you would have to take the derivative of that. Typically, we just take the derivative of it and put it on the top of the fraction, kind of like we do with square roots. Okay, like if you have a square root of 2x, you're going to have 1 over 2 times the square root of 2x, and then the derivative of 2x would be 2x. You put that up top. So it's kind of the same thing there. So like if we have the derivative of just a straightforward sine inverse of x, this would just be 1 over the square root of 1 minus x squared. Okay, and because you would take basically the derivative of the inside, the derivative of x is 1, so you'd have times 1, or you would put the 1 on the top. Either way, it's the same thing. Okay, so there's 3 more derivatives you have to remember, and that is the last derivatives that you will learn this year. Okay, from here on out, we'll do the basically the integrals going backwards from this, and then we will use basically just finish off the year with some application stuff. So there's the last 3 new derivatives. You will not be learning any new derivatives for the rest of the year. So let's do some examples of this now. So we want to arc sine of 2x, first of all. You can write it, again, you could write it one of 2 ways. Square root of 1 minus, the inside is u, which is 2x, squared, times the derivative of 2x, which is 2. Which again, you could just put that on the numerator of the fraction, it's the same thing. So 2 over, I'm left with under my square root, 1 minus 4x squared. So there's your final answer for that one. Next, arctan of 3x. And again, you just got these derivative functions, so you probably don't have them memorized yet unless you're a visual learner and you can just look at something and have it memorized the first time you see it. So we may need to come back and just kind of take a peek at this. This is our derivative for tangent, u prime over 1 plus u squared. So we can do this the shortcut way. U prime would be the derivative of the inside, which is just 3. And then the denominator is 1 plus, and then square that, we get 9x squared. Okay, so that's your final answer. We can't do anything with that to simplify it. That's it, we're done. And an arc cosine. Remember, cosine is the same thing as sine, it's just negative. Okay, so we have negative, let's do the denominator first, so square root of 1 minus u squared. U is now the square root of x. So if we square that, we just end up with x. And on the numerator, we need to put the derivative of the inside. So the derivative of square root of x, hopefully you've done this enough times now that you know it's 1 over 2 square root of x. If not, we pull that out to the side and we say x to the 1/2. And again, we're going to bring that out front. So 1/2 x subtracted by 1 to the negative 1/2. So that's where we get that from. Now let's clean that up. This is negative 1 over, there's a 2 out front, the square root of x and this stuff are both under square roots, so we can say square root of x times 1 minus x. We could also see this written as 1 over 2 square root of x minus x squared. Again, you're looking at your multiple choice answers and seeing which one matches your answer or can be changed to match your answer. Okay, so any of those would be acceptable. Those are all correct answers. And one more here. We're going to look at the secant function. I don't remember the secant function, so let's come back and cheat a little bit here. So here we go. This is our secant function. Okay, so u prime over absolute value of u, square root of u squared minus 1. And again, make sure you keep the difference there. 1 minus u squared minus 1. Make sure you have those separated there. So, all right. So let's go ahead and cut back up here. So just so we don't forget it, u prime over absolute value of u, square root of u squared minus 1. Okay. So let's go ahead and do our derivative here. So let's look at the denominator. U, again, this inside function here is u. So e to the 2x is u. Alright, so we're going to have absolute value of e to the 2x. Now, if the absolute values are not necessary, you don't need to put them there. Is it possible for us to get a negative answer here out of e to the 2x? And that answer is no, we cannot. This would always be positive. It's a small fraction if we plug in a negative number for x, and then at 0 it's 1, and then the bigger the number is for x, it keeps growing. So just keep that in mind. We don't really need the absolute values there, but sometimes your answers will have them. So now we're going to square this. So what happens when we square e to the 2x? So e to the 2x, and then we're squaring that, minus 1. So I'll give you a second to think about what happens here while I do the derivative of e for the numerator. So again, derivative for exponential, we recopy it, e to the 2x. If the base is something other than e, we need to have ln of the base, but because the base is e, this right here just becomes 1, so we don't need to write that. And then we have another chain rule because we have to take the derivative of 2x, which is 2. So a lot of stuff happening there. So rewrite, simplify our numerator. The denominator, we no longer need the absolute values there. And let's come back to this e to the 2x squared. What is that? Hopefully you realize that that is just e to the 4x, because we're just multiplying exponents, minus 1. There's your final answer for that one. All right, here's some practice problems, and again, like always, if you have any questions, let me know, and I will get back to you.